So, about a year ago, I had a problem. I was working with a couple friends on a mobile game called Flappy Royale. We were a 99 player battle royale version of Flappy Bird, and we decided we wanted to launch a public beta. So we just tweeted about the game from our public Twitter accounts. We had some test file links, Google Play beta links, and within 3 days, we had almost 200,000 daily active users. Which sounds incredible and great and delightful and everything you want for your mobile game. But it's not great when your servers are suddenly costing you hundreds of dollars a day and there's no way for you to make money from your users because your ad providers haven't accepted you yet and all that stuff. So I spent the next few weeks frantically refactoring the entire game to not lose us the shirts off our back. So hi, my name's Em. I use she, her, they, them pronouns. I work as a senior cloud advocate at Microsoft. And as mentioned, I'm based in Toronto, so I'm your token North American for the day. And so my goal for this talk is really twofold. I want to tell you about our journey so you can avoid making the same mistakes we made. If you're not familiar with building out multiplayer games, maybe give you a taste for sort of what this sort of optimization and refactoring your cloud architecture can look like. If you're already familiar with this stuff, maybe the sort of serverless tech I'm going to talk about will be inspiring. But also at a larger level, I think sort of an argument I want to make is that the onset of cloud computing and serverless and all these buzzwords I'm going to keep using have sort of categorically made it possible to make weird experimental independent multiplayer games in ways that weren't really possible a few years ago. So to start with that second point, I want to take a step back and look at the history of online games in general for a few minutes, if you'll sort of indulge me as a history nerd. And I would argue that originally it was really easy to make multiplayer games, and then technology grew and the market shifted to a point where that was generally really accessible to small teams. And now, with all sorts of cloud technologies, we're now at a place where this is possible again for small teams to do at scale. It goes without saying, history is not a clean single line, but I think this is still a helpful framing to understand where we are. So, to my knowledge, the first real-time online multiplayer game is the original MUD, Multi-User Dungeon, first built in 1978 at the University of Essex, and then it came online to ARPANET and other universities in 1980. And it's really representative of the first decade or two of online games, modulo BBS door games and stuff like that. But generally, there's the single physical server that hosts it where if you're playing the game, you probably know the person who was hosting it in real life. And the history of MUDs, this entire genre of text-based multiplayer game inspired by the original MUD, was really one of college students and researchers saying, this game's really cool, let's build our own version or modify our own version on our own server. And if we fast forward a couple decades to the early 90s, we start getting games like Doom and Quake and other first-person shooters and real-time strategy games, and even as you're still playing against strangers, it's still fundamentally a peer-to-peer model. So you as a game creator, you might have a centralized matchmaking server you need to maintain, but players are still connecting to each other to play, and you, as a developer, don't have the overhead of running these heavy multiplayer game servers. This really changed in 1996 and 1997 with Meridian 59 and Ultima Online, the first of what we now call MMOs, what would have really been called graphical MUDs at the time. Separately, if you want to nerd out about history, I would argue strongly that the first graphical MMO was really LucasArts' 1984 game Habitat. But at me on Discord later if you want to nerd out. Because I think really for what I'm talking about, Ultima Online is really what's important, even though Meridian 59 technically beat it to market, because it's the one that has historical significance. And that sort of when the developers were building it, they knew they were going to have to solve a problem that they hadn't had to solve in other online games before. It was going to be, by any projections, a single game with a large enough player base that not everybody could play on the same server. And they knew they needed to break the game up into different instances with different player bases. And this is really common today with different, MMOs having different servers you have to log on to. But that was going to be a really weird and foreign concept to MUD players who are used to playing with their friends and be able to find their friends easily and have this concept of a single shared world that can build up its own history and culture instead of potentially fragmenting that so different servers have different shared cultural norms. This was such a weird and novel idea at the time that they knew they needed to develop an in-fiction explanation within the game of why it was like this. So the world of Ultima Online was one where a giant crystal shattered into a million different shards, and you were choosing which shard representing a sliver of the universe you were playing on. And to underscore, this was so radical at the time that non-game web developers still use the same terminology today. Like if you deal with maintaining relational databases on servers, you're probably talking about your sharding strategy. And I find it so ridiculous that this like very common industry term literally refers to Ultima Online in-world lore to cover up this problem. So from there, like Ultima and Meridian really kicked off this new era of online games and MMOs, and sort of expanding the audience and the expected scope of games to a point where running a live online game really required a huge budget. And the barrier to entry became unreasonable. So even in the early 2000s, when you have this Cambrian explosion of games like Second Life and EVE Online and the original Star Wars Galaxies doing really conceptually interesting things, they were all either made by large existing studios or smaller startups that had VC funding or licenses or some way to get them to the scale really easily. I think from there, it took a couple years until we really got to Facebook games for things to start to democratize a bit again and to make it possible for smaller teams to viably make multiplayer games again. So Words with Friends is one of the first games I commercially worked on, and I think about it a lot. If you're not familiar with it, it is Scrabble on your phone, but asynchronous. But I think it does a really good job at is about the time it came out, Ruby on Rails as a web development technology was just starting to be popular. And Rails made it really easy for tiny 3-person startups to build websites and web apps that essentially looked like databases, where you could store data in the database and retrieve it from the database. And the genius thing that the Words with Friends creators did was they built a game based around that. Like, this is a game that, because it's a turn-based game where you can just store moves or board state in a database, your backend service is Ruby on Rails instead of this very heavy bespoke traditional MMO system. And so even compared to other Facebook games, like when I worked at Zynga, Words with Friends had 10 times as many users as any other Zynga game on a tenth as many app servers, because it was just it was so clearly designed to fit the grain of this easy to use technology. Which brings me to talking about Flappy Royale, because I think it is also a really great example of this, and I'll go through all of the sort of serverless stuff that we're using, but I think to me it is a continuation of this argument that having cheap and accessible cloud computing brings us back to that early 1980s era of multiplayer game development, where even tiny teams can make weird experimental games on no budget. So, as I said, I'm going to be talking you through our journey working on Flappy Royale. It is a 99-player, last bird standing battle royale version of Flappy Bird, where you're just trying to survive longer than everyone else. I assume for an audience of game developers, I probably don't need to spend very much time on this, but Flappy Bird was a legendarily popular mobile game of what we now call hyper casual from 2014, a brutally difficult one-button game. There are a million Flappy Bird clones out there. There's a lot of racism and bad things around the creator taking the game down. Battle royales are one of the biggest genres on the planet. They're usually third-person action games, but not necessarily. I think to me, sort of one of the crucial pieces of them is that you're playing against 99 players and have this really exciting sense of competition. So Flappy Royale is a pretty straightforward mashup of these. You are just playing Flappy Bird, but you can see all of the other 99 players you're playing against. You're not interacting with them. Your goal is to just survive longer than them. So instead of being a high score chaser, you just need to beat everyone else. And we really had a couple different design goals with it. First of all, we were just really interested in, is this a fun mashup? Like, it's a fun joke, but we think this actually adds something compelling to the Flappy Royale formula. We were also really interested in the sense of archival work. So Zach Gage, one of the three of us who worked on this project, was sort of noticing that even though there are a million Flappy Bird clones, none of them actually feel like Flappy Bird. They do not have like the very specific game feel that made Flappy Bird famous. And he happened to have a Unity project. So when Flappy Bird was still around, he spent a day making a game feel perfect clone. That of course, because it was a 5 to 10-year-old Unity project, it wouldn't compile. We were able to dig out an old laptop to run a Unity web player build we had. And so we were really happy to put out, great, we now have the sort of reference implementation of a game that feels like Flappy Bird did, but it is also open source and it is a modern JavaScript code base that we can hopefully keep up to date pretty easily. But we also had sort of pretty non-standard goals for running a live game that Zach was sort of partly involved while working on other projects. Like I think at the time he was shipping Cards of Darkness for the Apple Arcade launch. And my other collaborator, Orda, and I, we were both about to start full-time jobs. So there is this hope of, we want to put this game out there. We're going to give people ways to give us some money from it to pay the bills. But we don't want this to be a full-time live service game where we're actively maintaining it. So we want something that is as easy as possible to maintain without us thinking about it. I'm not going to talk about building the actual game client itself. It's all on GitHub if you're curious. We're using TypeScript. We're using Phaser as our game engine. You can check it out. I want to talk about sort of the server side of things instead. And a general theme of everything we did, sort of similar to Words with Friends, is that traditional games netcode is really, really hard. And if we could find ways to avoid having to have, a networked physics sandbox and deal with that, that's great. We're lazy. Looking at other ways we can solve this with design. And separate from that, we had a couple other specific design challenges we were interested in solving that would have other repercussions as well. One of which is, if we have a game that is live and is multiplayer, but we are not actively maintaining it as a live service game, we know that we're going to lose players over time, and we want to make sure that you always have a fun game to play with. So there was an MMO version of Flappy Bird called Flappy MMO. That's a typo on the slide. And it's great. It was from when Flappy Bird was first a thing. You can still play it today, but there is no one else playing with you because no one is playing Flappy MMO in 2020. So we were really curious of, can we make sure that people will always have a fun, exciting, competitive game to play? Oh, it animates. Great. The obvious solution to this is bots. This is really, really common in sort of .io style games, even ones that don't advertise themselves as using bots, but if they're mobile games, you can usually put your phone on airplane mode, and it's really easy to tell. We didn't want to do that. The easy joke answer is we were too lazy to build a Flappy Bird AI, but it also just didn't feel right. Like putting on our sort of independent artists hats, if we were going to give people the experience of playing a live game against real people, it felt like cheating to have them be bots. And you see this a lot in sort of actual battle royales. Like a lot of mobile battle royale games will start you out against bots and sort of ease you into playing against other humans. And players hate that and are so frustrated and feel like developers are sort of talking down to them. But we had an interesting observation, which was the game we designed was more or less competitive solitaire. Like, it is really important that you can see the other players and see what they're doing and see how well you're doing relative to everyone else as the pack thins out, but you don't actually interact with them, which means maybe this doesn't actually need to be real time. So we ended up building out a ghost system. So when you click the ready button and load into the game world in your little pixelated battle bus, we go to the server and we say, hey, this is the level we're playing. Give us recordings for the 99 people who played this level most recently. And you play against those recordings, and then when you're done, we take the recording we just made of you and upload that to the server. So the next person who comes to this level plays against 98 of the same people you did and you. And so this worked really, really great. Because this isn't real time, this means we avoid a lot of really, really hard netcode problems. This means that you always have someone to play against and you always have a fresh game, even if the game is dead enough that it's been days since someone else played. We could even offer an offline mode if we really wanted to. This seems great. So we set out to build this. We started out by basically creating a recording format so we could play back the game data in game, just tracking, a timestamp as an offset from when the round started, tracking, when did you press the flat button, when did you die, and then we ended up adding sort of sync y-axis checks. So, we're not running a deterministic game engine. That is a much harder problem. So instead of dealing with the physics getting out of sync, we just snap your Y position every so often, every couple hundred milliseconds. And so we actually needed a way to manage these recordings. And we started out by pulling in Firebase. If you're not familiar with Firebase, it is Google's sort of broad class of cloud services that are meant to be accessible. Firestore specifically is what people tend to talk about, which is a real-time database. So without having to like build a server, we can just call database functions from the client, and say, hey, I'm going to upload recordings, I'm going to retrieve recordings, and it is real time, where real time is on the order of hundreds of milliseconds. So, not fast enough to build an actual real time Flappy Bird, but fast enough for what we're doing. And so conceptually, we really just needed to do three different things. Like, no matter what our quote unquote server looks like, we need to like upload and download these recordings, and we also needed to manage level seeds. So given that we wanted an arbitrarily large number of different levels, we didn't really have a good sense of, are players going to get frustrated if they're playing the same level over and over again, because it's hard to judge that with Flappy Bird. We sort of came up with a pretty simple level generation algorithm that was seeded, meaning you could give it a number or a string and it would always give you the same level at any time. So we just needed a server function or a flat file or something that could say, hey, here is the list of levels that are available to play today, and we could scale that up or down depending on whatever we felt like or player feedback. And then it also let us add in a daily challenge mode, which a lot of games that use random number generation and procedural generation have, where every day, here is a single level that everyone in the world plays. We give you 10 different tries, and your highest score goes in a global leaderboard of all players in the world as a second game mode. So we need a way to do that sort of seed function, which raises a question of, what does it actually mean to like have a server? And there are a bunch of different levels of abstraction you can think at. At the simplest level, you might, buy a physical server in a rack in a data center, or take an old computer in your office and run a server on that. If you want to jump a reasonable level up in abstraction, you might go somewhere like DigitalOcean or Linode or these sort of VPS services, where you're conceptually renting a server. And you're like, I'm paying you for a virtualized Linux box or Windows box that I'm going to do whatever I want with. And if I want to scale, I'm going to buy more servers from you. At a level even higher, you might go to someone like Heroku, these platforms as a service, where instead of saying, I want to buy a server and configuring that server, you're going to say, I have a Ruby on Rails app, I have a Node.js app, I'm going to give you a bundle of code, and your job is to deploy that for me. And you're still conceptually saying, I'm paying for a server, or I'm paying for 10 servers, deploy my same code to all those 10 servers, but you're not thinking about configuring servers, you're thinking about delivering software to those servers. And then at the sort of highest level of abstraction, and also the newest, is this new serverless trend, where you're not thinking at the level of servers at all. If you're dealing with cloud functions, you might say, hey, I have a JavaScript function or a C# function. I want there to be an HTTP endpoint where whenever someone hits this endpoint, I want you to call this function. And I don't care what the infrastructure looks like under the hood. I just want you to charge me a fraction of a cent anytime someone calls this function, and I want it to just work whether I have one user or 20 million users. So that's what we ended up going with, because we didn't want to have to think about maintaining our own servers and thinking about scaling, as we were hopefully moving on with our lives to other projects while still running this live game and trying to solve this impossible problem. So this is relatively uninteresting code. You can just see we had something that just spit out a JSON object with a bunch of strings to be level seeds for the normal levels, as well as strings for the daily challenges. And great, this 20 lines of code gave us those seeds, which gives us everything we need. So at launch, you open up the game starts by hitting that function, which is using Firebase Cloud Functions, and it gets a list of levels. It picks a level that you're going to play. It directly hits the database and says, great, give me 99 recordings. I think it actually grabs like 200 recordings and samples them. You're going to play the game, you're going to have some fun, and then we upload your recording to the server. Great, pretty straightforward. We don't really have any servers other than that one function and this database. As a quick aside, daily challenges, we're also using recordings, but then manually doing that leaderboard happened in the client. And we also were just storing metadata about what your name was and what cosmetic items you were wearing in that database in a way that, like, even though we had some restrictions on the database, it wasn't that secure and was going to make it really hard to do things like having, like, we eventually added like loot boxes for cosmetics, and like tracking all that would have been not really viable in the system. But then, as mentioned, we went viral. and our costs started ballooning. We hit 180,000 daily active users. We maxed out Apple's 10,000 install limit on TestFlight in 3 days, which I have heard people who have maxed out TestFlight not in 3 days. And so we had these giant Firebase bills that, to put in perspective, still came out to, 0.2 of a cent per user per day. But that's a problem when you're trying to build this sort of long-lasting game and people are going to keep coming back and you're not getting any revenue out of them, even though the servers are still live. So we approached this problem in two different ways, really. We started by moving sort of a lot of generic gamey functionality to a service called PlayFab that I'll talk about in a minute, which then let us focus on the stuff that was really specific to Flappy Royale and move that away from Firestore to something more performant. Or cost efficient, I guess is the better term. So in that previous slide, talking about the ways you can quote unquote have a server, there's sort of another layer of abstraction on top of that, which is the best code to maintain is code that doesn't actually exist and isn't written by you. So instead of writing code and deploying it to a server, what if someone has already built the tool that you need? And for us, this ended up being PlayFab, which is a hosted LiveOps platform acquired by Microsoft a year or two ago, that basically their goal is to give you everything you need to run a live game. They pitch a lot of their work at large MMOs and AAA studios and stuff like that. But it worked really, really well for our purposes. And we were able to offload a lot of really, really core game systems to them instead of reinventing the wheel. So we moved all of our user authentication over to them, which let us easily add, automatically log in with Google Play Games and Apple Game Center. We could store our stats that were on each individual device onto the cloud, which let us build out these really, really cool like data visualizations so like players could see a histogram of their score over time, on top of like our own internal analytics, which got a lot richer. We were able to rip out the entire leaderboard function that, as I mentioned, had been this sort of gnarly duct tape solution on top of the recording system. And we were able to just use the leaderboard API they provide, which on top of probably being far more resilient to attacks, like thinking about the keynote we just saw, it also let us build out new features that we wouldn't have been able to build otherwise, like that view on the right of being able to see like both who is at the top of the leaderboard as well as like who are the people immediately around you and who do you need to build next, because like that, doing that sort of thing on the client by going through the entire world's worth of recordings was going to be way too computationally expensive. A really hard problem we had was there was a user who was consistently in the top 5 daily challenges whose username was offensive. And like, not in that it had a bad word, like we had a pretty naive like ban list of words in a way that we couldn't easily catch. And we didn't really just want to ban them. That wasn't a long-term solution. It turns out PlayFab has a third-party plugin called Community Sift, this company that does moderation. If you're already using PlayFab's authentication flow, you literally click a button and enter a credit card number, and they start rejecting usernames for being offensive. And it worked really great for us, and you'll see we're paying them a lot of money relative to everything else we're now paying, but that was totally worth it to not have to think about this like incredibly hard problem whose solution probably would have involved a bunch of like AI and machine learning and garbage we didn't want to deal with when our goal was to make a fun little game as an art project. We also ended up using them for economy management. So we added in, eventually, depending on how well you do in game, you might unlock an egg of a certain rarity, which is basically a loot box. You watch an incentivized video ad and you open it up and get a random piece of cosmetics based off of the type of loot box. And we were able to flow that entirely through PlayFab. So we had a catalog in PlayFab of all of our items and all of the loot boxes with like drop tables and drop rates in PlayFab. It was able to automatically receive a hook from our ad provider that a user watched the ad, assign them the loot box, open it for them, assign the loot to their account. That was just really, really cool. And so all of this was like, all of these problems we are solving are problems that live games have to solve. It is not what made Flappy Royale interesting. And it was really great that we could just take all of that and offload it onto this other service that at the time was not costing us any money. Like, they have shifted their pricing around since. So there's sort of an asterisk there. Like, I'm not telling you will be able to use this for free, although I think it is still very affordable for a use case like ours. But they just solved this problem and let us focus on the actual weird hard recording stuff, which is really important. So from there, we had to figure out how do we take our game specific logic and optimize that, which probably means moving away from Firestore. Because if you like the way we were using Firestore, each game was either one read or 100 reads, depending on how that worked, and one write to our database. Which, if your average play session is 10 or 15 games, and maybe your average player has multiple play sessions per day, and you have hundreds of thousands of users, that blows up really quickly. So we started by optimizing our reads. Normally, the way you would optimize like reading data from a database is through a caching layer in front of it. Unfortunately, that wasn't really viable for us because the way our game works, where we upload a new recording every time you play, the act of you downloading data and playing cache busts, and we can no longer use that cache data, which is a problem. So we ended up sort of compromising on our core idea that you're playing the game that like the immediate person before you played. Like the goal is so that you're always playing an exciting new competitive game against other people. It never feels the same, and conceptually that you're playing against people who played recently. That doesn't require it to be literally the last person who played. So we ended up saying, every hour we're going to run a batch script that grabs the 100 most recent recordings and shoves them to a flat file that we can upload to a web server and download really cheaply. And running that every hour still maintains the spirit of what we wanted to do, while also making it way cheaper for clients to download this because they're not doing all this database access. Once we did that, it was also easy to move our writes from writing to this fancy real-time database where we no longer need hundreds of milliseconds of real-time access, and move that again to writing those to flat files. And so with all of that shift, and like we also happen to move things to Azure to make it easier with PlayFab. But long story short, that sort of brought everything down. And we had this concept of Firebase or Azure is doing all of our game-specific storage logic, keeping things in flat files and some cloud functions. And we also had sort of a cold storage of every game that was ever played in case we ever wanted to analyze it. And then we had PlayFab doing everything else, which worked really well and cost us almost nothing. These are US dollars, not Australian dollars. That's like $80 a month Australian for community SIF, not 50, but still very cheap. It's costing us way less now because we have way fewer users. We're no longer live on Google Play because we're currently fighting Google because they think we're copyright infringement, and we're still currently fighting iOS 14. So we currently have very few players, some web players and old people who still have the old Android or iOS APKs or IPAs installed. But the big picture is if we got to a point where we hit 10 times or 100 times new users again, I would be deeply concerned with how are we running this as a live game? How are we engaging users? How are we scaling our community and our content? But our costs wouldn't scale anywhere near the way that it did before. And so some haters might say, you didn't actually build a battle royale, you just built a mobile game. I think what matters to me is that this sort of emotionally feels like the joy of playing a battle royale with other people, even if you are not really playing in real time. And so I think to me what is interesting about this, and hopefully useful to all of you, is looking at sort of our path to optimizing this custom sort of non-real-time system, like giving you a sense of what is possible for making these sorts of weird experiments. Like that it can feel real time even if it's not, and thinking about what are the trade-offs you need to make when designing your game and designing your architecture in tandem, since they're so deeply intertwined. And again, thinking back to like Words with Friends and thinking about what other technologies do you know, even if you're someone who isn't familiar with all of these server technologies yet. Thinking about there are these pieces of tech out there that are really accessible and really easy to use. And even if everything I just said sounds really scary and confusing, I promise this is so easy to get started with. And it's really easy to dive in and design something that is purpose-built for these systems and works really well and lets you make something new and fun and joyful. And that's really what I want to leave you with. That again, the server tech doesn't have to be scary. You can make something simple and small, and yet, because of the world we live in 2020, it scales. And that's all I got. Thanks.
Excellent. Thank you.